Welcome to episode 52, Space Show, an educational approach to planetary defense and near-Earth orbits. Asteroids have us in our sight. The dinosaurs didn't have a space program, so they're not here to talk about these problems, but we are, and we have the power to do something about it. I don't want to be the embarrassment of the galaxy to have had the power to deflect an asteroid and then not end up going extinct. End of quote, Neil deGrasse Tyson. Our planet must be protected from collisions, from space debris, or near-Earth objects. It's essential to raise awareness of future generations and involvement of the present ones in the search for possible solutions to avoid the destruction of the so-called cradle of humanity. In today's space show, we'll explore the basics of planetary defense and discuss why protecting planet Earth from asteroids is a global effort. The episode will focus on how an educational approach to planetary defense brings together different disciplines, promotes diversity, inclusiveness, and enables everyone interested in learning about this topic. So now, without further ado, please welcome our very special guest today, Mr. Jeff Woytach. He is an aerospace engineer at NASA's John H. Glenn Research Center. Mr. Woytach also provides systems engineering support to the Psyche mission, which will visit an asteroid believed to be composed entirely of metal. And welcome Nancy Wolfson. She's the vice chair of the International Astronautical Federation and Technical Committee of Near-Earth Orbits. So without further ado, I hand over the floor to our first speaker. Jeff, the floor is all yours. Thank you for being with us today.
Thank you, Tihian. Thank you for inviting me here. And Nancy, thank you as well. And let me extend my welcome to everyone here today. Talking about asteroid impacts on Earth is, of course, affecting everyone on the planet. The renowned astronomer and educator Carl Sagan described our world in, I think, the best way possible. He described us as a mote of dust in a sunbeam. And we'll talk a little bit more about that quote here as we go on. But let me go ahead and share my screen here with some charts. And as I mentioned, and as Tihian mentioned, we are looking at protecting our home. This is indeed the cradle of humanity. But that, of course, as Konstantin Tsiolkovsky said, one cannot live in the cradle forever. Though we have been exploring space and understanding space for the last 60 years, we are still in the infancy of what we are able to do in space. When we look at the night sky, we tend to think of space as almost two-dimensional, this dark blanket with twinkling lights covering the Earth. But we have to remember that space, or really space-time, is four-dimensional. And that when we look at those stars shining in the night sky, we are looking backwards in time. Even when we look at our own solar system, we are looking backwards in time. This is our neighborhood, a very small part of the cosmos. When we look at the sun shining in the sky, we're seeing how the sun looked 8 minutes in the past, because that's how long it took sunlight to reach us. And across our solar system, out to the Kuiper Belt, to the orbit of Pluto, it takes sunlight almost 5.5 hours. The thing to remember about our solar system is that it's not empty space. In addition to the 8 planets, we have comets, we have asteroids, we have moons. Between the orbits of Mars and Jupiter, we have the main asteroid belt, which is comprised of material of a planet that never formed. The Psyche mission will visit one of those asteroids that is believed to be part of the metallic core of that planet that never formed. Further out in the solar system, we have the Kuiper Belt, which is named after the Dutch astronomer Gerard Kuiper, which again consists of asteroids and other material. And even further out, the Oort cloud, named after astronomer Jan Oort, is where it is believed that the comets reside. But comets, asteroids are all the leftovers, the remnants of the formation of our solar system. And many of those threaten the Earth. This is a graphic from about 8 years ago that shows the count of potentially hazardous near-Earth asteroids that cross the orbit of the Earth and that are of a size to be of concern for impact on the Earth and the devastation that they could cause. So as you can see, what we look at as empty space is not truly empty space. Now, as I said, this was 8 years ago. NASA, National Aeronautics and Space Administration of the United States, has a planetary defense office, which has for the last 20 years been tracking these near-Earth approaching objects. As of 2 years ago, almost 20,000 near-Earth asteroids have been discovered and are being tracked. Over 100 near-Earth comets are known. And of these 20,000 asteroids, almost 2,000 of them are classified as potentially hazardous. Potentially hazardous means that they are of a size and of a material composition that should they impact the Earth, they would survive atmospheric entry and reach the surface of the Earth, causing devastation. 5 times or more a year, small asteroids actually do impact the Earth and release impact energy equivalent to about 1,000 tons of dynamite. In 2018 alone, 73 asteroids passed closer to the Earth than the distance between the Earth and the Moon. And even though this seems like a very large number of objects that we know and that we track, thanks to space-based and Earth-based assets, they are only a small fraction of what is out there. There are smaller objects which currently we cannot track. And there are objects that we find have passed the Earth only after they have gone past the Earth. And there are objects that we find only after they have entered Earth's atmosphere and actually caused some devastating problems. One of these occurred in 2013, when an asteroid fragment exploded in the air over Chelyabinsk, Russia. This was a relatively small fragment, about the size of a house, estimated between 12 and 13,000 metric tons, which entered the Earth's atmosphere at a speed of 19 kilometers per second. The light from the meteor as it burned up in the atmosphere was brighter than the sun, was visible from 100 kilometers distance. It exploded in an airburst almost 30 kilometers above the ground with an energy equivalent to 500,000 tons of dynamite. And this object went undetected before atmospheric entry. About 1,500 people were injured due to the indirect effects of the mid-air blast. Broken glass from windows were shattered when the shockwave of the explosion, and over 7,000 buildings in 6 cities were damaged by the shockwave. This was in a relatively sparse area. But imagine an object as small as this is exploding over the city of New York or Washington, D.C. in the United States, or over London, England, Tokyo, Japan, Rome, Italy, over major population centers. Imagine the effect of the blast causing broken glass and buildings to be damaged and debris coming down on the ground. An impact itself is not the only possible devastation. This was a relatively small asteroid that fortunately did not reach the ground. There have been evidence in the past of many other impacts of large items that have reached the ground. We look at, as Tihien mentioned, the extermination of the dinosaurs 60 million years ago was caused by a large asteroid fragment impacting off the coast of Central America, creating what is referred to as the Chicxulub crater. Chicxulub is Mayan for tail of the devil. The crater is hundreds of miles across and kilometers deep. There is a city in Germany which is inside a crater known as the Rice crater. It is the result of an enormous impact many millions of years in the past. And there are large impact craters evidence in Canada and the United States. Many of these have been eroded away over time because, of course, we have a dense atmosphere and we have weather, which tend to erode the evidence of these craters. But if we want evidence of impactors, all we have to do is look at Earth's moon and look at the number of craters visible on its surface. Look at the surface of Mars and the craters evident there. Look at Mercury, which the evidence of craters is there. So it is not a question of if Earth will experience another large impact. It is only a question of when. Therefore, it is important that every person understand the effects of these potential impacts, what can be done to detect these potential impactors in time, and what can be done to deflect them away from their trajectory so they do not impact Earth. One potential way is to detect an object when it's far enough away from Earth where we can actually deflect its orbit by impacting it. Just like firing a bullet from a gun would tend to deflect the target, we can do that provided we have enough energy to do that relative to the size of the object and that it is far enough away from Earth so that the deflection required is relatively small. Imagine if something is many, many thousands or hundreds of thousands of miles away, the angle to cause it to miss Earth is very small. The closer it gets to Earth, the greater that deflection would have to be. NASA and the European Space Agency are going to test this deflection theory. Later this year, they'll be launching a mission called the Double Asteroid Redirection Test, or DART mission. DART will be followed by a European Space Agency mission called Hera. The DART spacecraft will use an electric propulsion system, which actually was invented and developed by the NASA center where I work, the John Glenn Research Center in Cleveland, Ohio. This will rendezvous with an Earth-approaching asteroid called Didymos. Didymos is unique in that it has a smaller asteroid companion as a moonlet, and that companion was only recently named Dimorphos. In fact, the asteroid Didymos was only discovered in 1996, and it approaches the Earth. What DART will do is actually impact that small moon of Didymos to see if there is sufficient energy for that impact to change its orbit around Didymos. If that is the case, then we know that it is possible to deflect asteroids. Now, of course, the larger the asteroid, the more energy needed to deflect it. It could take one mission like DART. It could take 10 missions like DART. And obviously, no single country could ever hope to do this in the time needed to be able to deflect the asteroid. So this is one reason why it's important that this become literally a planetary defense issue. All of the spacefaring nations of Earth, all the industrialized countries of Earth would need to participate in this because Earth is the only home we have. We have to protect it. We don't have a choice. If we wish to survive, if we do not wish to become an extinct species like all of the dinosaurs, then this is something that we have to do together. And there may be objects out there that are going to be too large to deflect. We may need to be able to come up with some other type of method in order to slowly change its orbit over time. It's all dependent on the size of the object, whether or not we can detect it, and that will determine what we can do, if anything, about it. But it will definitely take a concerted effort around the world to be able to detect these objects, to have the facilities on Earth, have the spacecraft facilities to be able to detect these objects, whether they are large or even relatively small. Because even something relatively small, like that Chelyabinsk meteorite, can cause untold damage on the planet. This is a photograph of our solar system taken in 1990 by the Voyager 1 spacecraft before it left the solar system. The spacecraft was commanded to turn back and photograph where it came from. And you can read the quote here from Carl Sagan. And when you look at that mote of dust in a sunbeam, which is Earth, you realize that every human being that ever existed or ever will exist is on that mote of dust. And that little mote of dust is under attack by everything in the solar system. We, of course, have to worry about our own political misgivings and our own threats that we have to ourselves as a species. But if we move out into space and we look at Earth from this standpoint, we realize that we are truly one planet, one people. We are truly together on this world. And that's why we need to preserve it for all of us. Thank you.
Thank you, Jeff, for your presentation and showing us how to find and track near-Earth orbits. Can you give us an outlook on how definition of how these NEOs are characterized?
The asteroids, comets are composed of rocky material with volatiles like water within them. What we call comets are have a lot of volatiles. Of course, as they come closer to the sun, they heat up, and those volatiles are spewed off into a tail that we can see spread across our night sky sometimes. They are composed of carbonaceous material. Some are composed of nickel iron materials, and they are characterized by what they are made out of and how big they are. As they would approach Earth, for instance, they are moving at enormous velocities, many tens of kilometers per second. And of course, when they enter Earth's atmosphere at a steep angle, they heat up very quickly. So if they have volatiles in them, those volatiles would tend to expand quickly and the fragment will explode, like the Chelyabinsk, like the Tunguska event of 1908, which flattened tens of thousands of square kilometers of forest. That was an airburst. But then there are objects that are large enough and dense enough and have enough nickel iron that they will survive to the surface of the Earth. We find a lot of these, we call them meteorites, when these fragments reach the surface of Earth. They are fragments of these asteroids and comets. Many of them are in museums. The largest ones resulted in the Chicxulub crater that wiped out the dinosaurs. And we see evidence across the Earth of eroded craters, many of which are large enough to contain whole cities. But they're classified by material and size, and all of those things determine what we can do to help prevent their impact or deflect them.
So if Earth get hit by an asteroid like 66 million ago, it's game over, it's control or delete for civilization, like Bill Nye says. And I wasn't aware, you know, I'm a self-learned space enthusiast until I participated in all of this great outreach that our next speaker is going to introduce. I wasn't aware, and I was once in one of these, what was the event called? Anyhow, it was someone from the European Commission. He pulled me over and he said, you know what? After Second World War, we got the smartest scientists, the smartest people together in one room. And we asked this question, what is the biggest threat to humanity? We don't want any war anymore, no more war. What would be the biggest threat on humanity? And the last people, everyone said this, that, you know, bioweapons. And the only two people that were still standing up was ESA and NASA, you know, asteroid impact. You know, this is something normal people don't think about, and that's why we have great people like Nancy out there doing great outreach, and also I learned about planetary defense at the International Space University, where in 2019 where we had to do workshops and scenarios. What happens if this asteroid is going to hit one part of the nations, the other people are going to support the other nation and all of that. So maybe Nancy, you can elaborate further on your work and how you raise the awareness and get people to work together. So Nancy, our next speaker, she's dialing in from Washington, D.C. today. She's a base scholar, researcher, speaker, entrepreneur, and currently the vice chair of the International Astronautical Federation, a technical committee on near-Earth objects. She is the chair of the recently formed Taksha Center for Planetary Defense, aiming to contribute to the development of global cooperation for planetary defense. She's also the president of Disrupting Space Company based in the US, and some of her most recent work include contributing to the International Asteroid Warning Network, signatory for UN Declaration for Asteroid Day. Her most recent speaking engagement include the United Nations Office for Outer Space Affairs, Planetary Defense Conference, the FIC, and the American Institute of Aeronautics and Astronautics, among many others. Nancy, I turn it to you.
Thank you, Ty. Thank you, everyone. Jeff, wonderful presentation. Thank you for all those wonderful details. And I'm very happy to be here. One of the objectives of this presentation will be to get you very, very curious about planetary defense so you can join us in any capacity you can. And that's one of my missions. So I will speak a little bit about myself, but I guess I should apologize in advance. I have cats, just in case. Let me see if I can share my screen.
Yeah, we don't want cats going extinct.
That's right. So let me see. So as my computer is going, so let me tell you why, after all the technical aspects that Jeff has shared with us, why planetary defense matters to everyone, not just the specialists, not just the experts. We have different areas in planetary defense that it complements the technical aspects, and those are just as important as the technical aspects, because we need to understand, as Jeff said, at the end of the day, we are defending our planet, our only home. We have families, school, life as we know it. As somebody said, one of my friends from far away, Neil deGrasse, said, the chances that your tombstone will read killed by asteroid are about the same as they will be for kill in an airplane. So the threat is real.
Yeah.
The threat is real. And
it's not some billionaire hobby, talking about going extinction to sell the Mars mission. So it's actually real. And this could happen any time, any day, we can't see all of these threats,
Yeah, just as Jeff said, and one of my favorite organizations, B612 Foundation, said recently, it's not a matter of like if we are going to get hit or not, it's when. Are we prepared? Do we have what we need to mitigate in case of our population is well informed in what to do? So those are things that we're still in the process. We're still in the process. We're still learning what is needed. And I have to say, COVID-19 has been an amazing, tragic, but it's still on the good side, an amazing example of what to do in case of a global disaster, which at the end of the day, an asteroid impact could be easily considered a global disaster with global consequences. Okay, so, and the last one I'm going to share with you before I go into my presentation is by Rusty. we know Rusty, one of our dear astronauts, there is no accepted, and this is very, very interesting and very important, there is not accepted global policy on what to do about asteroids impacts, because our agencies are still developing the process of what to do in case of an impact. And we are still coordinating those efforts. And we are still developing communication processes and the work that we're going to do between agencies. So that is something that I want to bring to your attention before I start my presentation, because we will discuss this as I go. Ty, you let me know if my screen is sharing. Am I on?
Yes, you're on full screen.
Okay, excellent. Thank you. So as you can see, our presentation today is titled An Educational Approach to Planetary Defense. My name is Nancy C. Wolson, and as Ty said, I am the Vice Chair of the International Astronautical Congress Committee on Near Earth Objects. My work in planetary defense is focused on research, education, management, and communication. Whoa, there you go. Now, the United Nations have developed the 17 Sustainable Development Goals. For this presentation, we are going to briefly discuss the 4, which is quality education. Why quality education? And education itself as a broad concept is so important in planetary defense. So what the United Nations says, the goal aims to ensure inclusive and equitable quality education and promote lifelong learning opportunities for all. It also aims to provide equal access to affordable vocational training, to eliminate gender and wealth disparities, and achieve universal access to a quality higher education. A few things that, of course, space technology has contributed to enhance the quality of our education is high-speed internet connectivity and tailored online educational content delivery via satellites. We also are aiming electronic attendance, mentoring, and provision of incentives for parents to reduce dropout rates. Last, remote learning, e-learning, and lifelong learning opportunities for remote and isolated communities. So if we take all of this into planetary defense, in case of an impact, we will need, especially the local community, be able to participate in the process, in the mitigation process. So education is very important. What do we do? Who we are? What is the threat, and what the threat means for our society? Oh, okay. So this is, you already know, I work for the IAF, NEO Committee of Technical Committee of Near Earth Objects. I'm also part of the UN Asteroid Day Declaration, which focus on raising awareness about planetary defense. Can we get, I'm trying to move this, sorry guys, let me know if I lose you. Okay, can we get everyone to pay attention to this topic? One of the objectives is we, the experts, have the responsibility to encourage students and young professionals to grow their involvement in the field. The intention of this presentation is to encourage the experts to continue creating platforms that can motivate others to get involved, and hope by introducing important educational initiatives. Here, I'm hoping that I will encourage everyone watching us today to pay attention to this topic, and hopefully at the end of this presentation, you will be interested in joining some of the initiatives that we have in place in our community. And another objective is Well, we already spoke about this. And we want to, of course, educate the general public as we continue motivating everyone to get involved in planetary defense. So this is about our NEOs, a little bit about NEOs. And as you see, Jeff already shared some of this information with us. So as you can see the numbers on your screen, you have been given these numbers already. The only one that I'm going to share with you in this one is that known near-Earth asteroids larger than 140 meters left to be found is, and this is what we think, approximately 15. As you can see it, 15. I can't see. Oh my God, I lost it. Sorry. Did I miss that one? Oof. Uh-oh. Okay, I can go back, but you saw it in your screen. Now, Jeff also shared already what the Chelyabinsk meteor and the Tunguska, if I'm not pronouncing it right, in Siberia in 1908, right? And you can see in your screen also, this is one of the largest pieces of asteroids found in Russia after one of the impacts. And this one is think to be about 500 what is it kilograms, if I'm not mistaken. So it's the largest one found so far. What this incident means to us, I will not go into the technical details because we already got that. So what I'm going to focus in what they mean for us. One of the interesting factors of this specific impact is scientists gather crucial information that went into their official reports from the Chelyabinsk eyewitnesses. Okay, so most of the material, the amazing material that we actually gather from this specific event came from the people, just people, common people on their cell phones, their cameras, from their homes, in their cars, driving and just watching this happening right in front of them. Without them, we will not be able to have this much material to be able to be analyzed by the experts. Another interesting fact is that after the incident happened, our Earth experts went into the village and they went into the streets and they talked to people. And the findings are detailed in many different published papers. Some of the papers are distributed in the Nature and Science magazines. And the scientists compiled all the data from their visits and interviews, as well as the online survey of residents, and calculated the damage and injury patterns around this specific event, and including experts from Seti, the University of Western Ontario, Colorado State University, of course, our researchers from NASA. And these amateur videos have been filmed, photographed, and calibrated. They were able to get all this material and calibrated the meteor precise location and the path that it took through the atmosphere, thanks to all this material given by people in their own way. So we, the specialists, cannot say we are the only ones working on this, because at the end of the day, we will need everyone to be involved, and we need to continue creating platforms for everyone to be involved. Let's go to the next one. There you go. Now you have one of those awesome photos, our dinosaurs, and we already know about this event. So one of the interesting things, let me see if I can go back, that I missed, and that will be probably one of the opportunities that our students would like to to participate in the near future if they wish to get involved in our field, which is asteroid hunters. Fascinating. You go there, you get a piece of this. They have a specific conditions. How can you tell if a rock is from a space, right? So one of these, the meteorites are rich in iron. They stick to magnets. But of course, the larger the meteorite sits on Earth, the more it's exposed to oxygen, fertilizers, and other contaminated elements. So it's important for the experts to find these materials as soon as possible so they can be analyzed, right? Also, some of these little pieces, as you can see in the photo on your screen, they have specific patterns, geometric structures unique to iron meteorites. And some of the meteorites are packed with gemstones. Now, please don't go running and create your own mission and think, oh, I'm just going to go and find a bunch. We have protocols. Most of these sites, you probably after the event, you need a specific permits to go in the area because these areas are still investigated. Okay, so our experts are still visiting those areas to see what else we can find after and continue creating reports of our findings, 3, 4, in our case, this will be 5, 5 or 6 years already, going from all the way 2015. Okay, let me see my next one. There you go. So now we already know about the asteroid that potentially killed the the dinosaurs. Let me find this. Now, one of the things that you see in your screen is, again, how do we relate all this information about the dinosaurs and 65 million years ago being killed and then landing to extinction, and also this event transformed the life in our planet. We don't know exactly where the asteroid came from, of course, and how it made it. It made its way to Earth. But one interesting fact is in 2007, a study using visible light data from ground-based telescopes first suggested the remains of a huge asteroid known as Batistina, my pronunciation, and as the possible subject of this one. So that's a quick fact that you can keep. And why should we care about asteroids and NEOs, near Earth objects? Because we don't want you to be overly concerned, okay? And this is something that I want to emphasize because working in the area of communication, we are very careful of a specific terminology because at the end of the day, we don't want people to be alarmed and think that this is it and we are going to die. Still, it's a little easier to die from any other natural disaster, including some, accidents, car accidents, disease, and other different, much different threats that we can experience that being killed by an asteroid. So as communicators, we have to be very careful to use very specific words that will not alarm people, but will actually motivate them to continue learning about asteroids and planetary defense activities. So in case of an impact, we can all share the information correctly, and we can all participate in case of we have to rebuild ourselves and our communities from whatever it is. So you see on your screen, it says the coronavirus disease in 2019. why am I keeping this? Why am I placing this one in this specific section? Because, as I said this before our presentation started, COVID-19 in the dark side, it's being terrible. What an unfortunate thing to happen to all of us globally. But it also have served as a good example of like how prepared are we to deal with a global losing my voice now. How ready are we to deal with a global disaster like this? You know, and the global consequences that COVID-19 has had, and we are still in the middle of, and hopefully we are going to get out of it. So there has been so many studies in relation to COVID-19, the pandemic, that could benefit planetary defense efforts and allow us to learn what we need to improve in terms of connectivity, communication, interagency collaboration, and of course, international collaboration. So, and on the good side, COVID-19 will continue serving as a subject of study for us, and we're gonna be taking the lessons learned from it and hopefully apply them to the different missions that we are organizing and the different campaigns that we continue designing. Okay, so I'm almost at the end. And Ty, let me know if I'm going over my time, please. Give me a check.
2 more minutes.
Okay, perfect. So if you are interested in planetary defense and NEO observation programs, these are some of the areas that you might be interested. So we have NEO discovery, NEO characterization, we have testing and mission planning. Are you interested in participating in deflection missions, disruption testing missions, campaign design, which is probably the area that I'm more aware of and fascinated by. And then we have, of course, a quick list of the current missions that we have here, ERA, Hayabusa 2, which is after Hayabusa, DART, Jeff already gave us a little bit of it, and OSIRIS-REx, right? And then through these specific missions, we have some very, that are getting well-known asteroids like Bennu and Dynamis and a few other ones. Then you have the legal and policy aspect of planetary defense. And as I said at the beginning, we don't have one cohesive and formal path to deal with the consequences of an asteroid impact jet. So our area of legal and policy is still working, and we have a few organizations, including the United Nations, of course, and also same page, which you will see it in the next one, and I will talk about it. Impact effects and disaster management. So you go into impact effects, disaster management, communication, and of course, education and public engagement. So these are a few of the different areas that our people could get interested and join us. And this is just a quick rundown of the latest educational initiatives that I have participated with some of my colleagues. This is with Linda Villens from NASA, Patrick Michel, of course, OSIRIS mission. He was one of the most involved scientists involved in this. And then we have, of course, our young professionals from the Space Generation NEO project. So, and this happened at the last Planetary Defense Conference in 2021, and it's published. You can find it online. If you want to read the whole summary of the paper that we all together, the four of us, work on, you can find it online, and you can just Google any of those names, and you will find this work. So the next one, the next planetary defense, will be in 2024, if I'm not mistaken. This is another one that happened with the American Institute of Aeronautics and Astronautics. And these are a few of my colleagues. Also, we have Mariela Graciano for GMV. She also works and collaborates in the DART and the mostly ERA mission. And then we have our young professionals, because I'm always trying to bring different generations, different perspectives, because planetary defense is not one straight line. We're going to always need a multidisciplinary approach to planetary defense. So it's extremely important that we get that multidisciplinary approach from different participants. Let's go to the last one. And this is one of the, I was fascinated by this specific project. So this is Seti. Seti, just a few years ago, understood that having an initiative that connects people, amateurs, and is a citizen science project connected to some real and tangible asteroids. I'm losing my words. A specific campaign for people to learn more about planetary defense and asteroids was really important. So what you can see right there in front of you is what we did not too long ago. In 2020, we got a campaign, and what we did is we gathered a few top experts in the field to judge what is going to be the next name for an asteroid that was recently discovered. Okay, so, and this campaign went on for a few months, and then eventually we decided that we are going to be putting forward our recommendation for the asteroid to be named Ada Carrera. Ada Carrera was an amazing astronomer. She passed away, unfortunately, not too long ago in 2020. And thanks to her career and the outreach, the education that she provided to the people around her and globally, we definitely think that it will be a really good idea to name the asteroid that was discovered by Seti after her name. Okay, so this is the last part. Resources for everyone. So if you are new to planetary defense, this is my most favorite part. And I really like this part because this is where I'm going to give you homework, okay? You will go into all these different names, and then you will find the different volunteer programs that they have. And we're gonna start with UN Spider, that's the United Nations, of course, disaster management. Then we have Asteroid Day, and I'm going to run through it as quick as I can because I know I'm running out of time. Asteroid Day, which is happening every June 30, and to remember the event from 1908, okay, that we spoke. Then we have, of course, B612, which is constantly also focusing on raising awareness, but also they work with the specialists in different missions. Then we have the International Asteroid Warning Network, which is working on having a cohesive communication process internationally and bringing the facts. And also all of these different organizations are dedicated to really dedicated to fight fake news, because when it comes to the communication aspect of planetary defense, that's a constant thing, you know, now with the internet, with social media and all of that, there is a lot of miscommunication about what asteroids can do, what it means to us, and what is happening tomorrow. So these organizations are the ones that you have to go for trust for the real information. So as you can see it on your side, and if you can find it online easily, just find it online, and you will be able to communicate, to get in touch with them. And most of them has a membership-based program, but also a volunteer program, which I really appreciate. Let me see if I could go to the next one. And I think that's the end of my presentation. It's a little early on my side, so I'm sorry, I'm a little sleepy today. So this was my presentation focused on an educational approach to planetary defense and NEOs. Protecting planet Earth from asteroids is not just the work of our experts, it's the work of everyone. So I really hope that after this presentation, you feel empowered and curious enough to seek more information in how you can get in touch with us and you can join some of our efforts. So thank you so much for having me today. And I am ready for all your questions. And thank you. Thank you for being with us today.
Thank you, Nancy, for your devotion to planetary defense outreach. We have many questions from the audience. I would like to open the floor now for Q&A. The first question addressed to Jeff, a more technical question. Why is it necessary to characterize a NEO that might impact Earth in order to develop a plan for an impact mitigation mission?
That's an excellent question. You know, as I said during my presentation, it depends on what we know about the asteroid, its size, its composition. Of course, it has to be tracked for a long time in order to determine its orbit. And so we can project that orbit forward in time to determine if it is a threat to the Earth or not. Is there some point where its orbit will intersect the Earth's orbit when both are in proximity to each other? So in some respects, it's a statistical game, if you will, but it's a very important factors that we have to take into account in determining which of these asteroids are threats to the Earth and which aren't. So its size, its composition, its knowledge of its orbit over time.
Diego asked, what is the asteroid's average size that can be considered a relevant threat, and how the monitoring alerting system infrastructure works?
You know, relative threat is actually a relative question. If you look at the Chelyabinsk fragment, it was relatively small. It was only tens of meters in diameter. So the question is, what is its composition? Is it going to burn up harmlessly in the atmosphere? Is it going to survive long enough and explode, creating a shock wave that can cause problems? Is it large enough to actually reach the surface of the Earth? You know, many people will say, well, over 70% of the Earth's surface is water, which is true. But if an impactor is large enough to come down into the ocean, you can create a tsunami that is obviously going to cause devastation. So it is not just the impacts themselves, but is the effects of the impacts that can cause the devastation. Again, going back 60 million years to the fragment that caused the eradication of the dinosaurs. The impact, the shock wave, the heat wave from the impact, of course, caused devastation. But the amount of material, earth, dirt that was thrown up into the atmosphere blocked out sunlight for many decades. And obviously, life on Earth needs the sun to survive. Without the sun, the plants can't survive. So it caused devastation of 75% of the Earth's species. That's animal life and plant life, which all had to come back again over time. So it's not just the impact itself, but it's the secondary effects from the impact that we also have to learn how to combat.
Joseph makes the comment here, the more man-made machines we send in orbit to protect from debris will themselves cause more debris from their expiry. Should we be moving to organic, decomposable materials?
That's a very interesting question, yes. You know, NASA and other space agencies adopted a plan a number of years ago that any object that we put into Earth orbit must have a way of being disposed of safely, either putting it high enough in orbit around the Earth where it is not an atmospheric entry threat, or making sure it does enter the atmosphere at a time and place at an angle such that it completely burns up and disintegrates in the atmosphere with nothing reaching the ground. That is for satellites, for launch vehicles and their upper stages. They have to have a limited life and have to be disposed of. Unfortunately, we have a massive cloud of debris in Earth orbit. Just recently, a very small piece of debris impacted the robotic arm on the International Space Station. This was probably something on the order of the size of a flake of paint. Very small size, very small mass. But when the space station is moving in orbit at 17,000 miles per hour, and this object is also moving toward it at a relative velocity of 17,000 miles per hour, even a flake of paint hitting at 35,000 miles per hour is going to cause a lot of damage. Fortunately, it hit the arm. It did not hit a pressurized module of the space station. There have been impacts on the pressurized modules of space station, but space station has been designed to withstand those small impacts. They actually have impact shields on the station, basically standoff pieces of metal that are designed to dissipate the energy of these small impacts. But even man-made debris, there have been times when the crew on the International Space Station has been directed to go to their Soyuz modules because a large piece of space debris has been tracked to be coming near the space station, and that there was a finite chance of it hitting the station. So it is a real danger. It's a known danger, but it is a danger where the space agencies of the world are looking to mitigate it.
Yeah, definitely. Just a quick thing on a space debris is very much related to the efforts that we have in planetary defense. And not too long ago, we had one of the Japanese shuttles crashing. It didn't happen just, like a month or so ago. So let me see, I don't quite remember exactly. Yeah, it's something that still is being investigated. But in terms of a space debris, we definitely need to start creating policies and in regards to what to do with the equipment that is pretty much staying there until something else happens with them. So yeah, it's a big issue.
Thank you, Nancy and Jeff, for these insights. We have two more questions. How will the Large Synoptic Survey Telescope contribute to finding, tracking, and characterizing near-Earth orbits, asteroids, near-Earth asteroids?
Yeah, it's another excellent question. I mean, the more infrastructure we have that can be used to track these objects, which is very, very difficult because, relatively speaking, given their distance from Earth, these are incredibly hard to find. And we find them by, of course, reflected light. Many of these, especially carbonaceous ones, are very, very dark, so they don't reflect much light. So you have to track a patch of sky for a long, long period of time and then look and see what's moved. And that can be very difficult to do. So the larger the telescope, the more light it can gather, the more objects it can image, and the smaller the objects it can image. And again, of course, the Earth is rotating. So to have these in place around the Earth where we can do continuous scanning and be able to find these objects is very important. A lot of it is done automatically. There are algorithms that search for objects that may have moved between images. There are amateur astronomers across the world who have literally found hundreds of these asteroids. And there are even students who have taken data that NASA has archived in the past and re-examined it and found things that have been missed. So it's important that we put all of these things together into one concerted effort to be able to look at data we already have and what data we're going to be getting in the future.
Thank you. Nancy, would you like to add on here?
Yes, going back to the space debris, actually, my apologies, it was a Chinese rocket. And probably you remember that one. Yes, you can correct me. I said it's early. In Washington, D.C., it's early. So yeah, and so space debris is one of those issues. But Ty, you wanted to ask me a question?
Would you like to add on to this question?
Oh, let me go to the next one. I think Jeff did an amazing job.
Okay, I think Jeff also covered how we assess asteroid impact risk. Let's future scenario. Let's say the agencies can detect a giant asteroid hitting China, you know, in 3 days. I think that there's a need for us to actually do a second episode on this, on ethics. You know, should the media, you know, should we make this public? Should we, you know, evacuate China? Should America care about China if a giant asteroid hits China? You know, what is the process there? Is there such a scenario already? You know, do we want the public to know that this is going to happen, and how are other nations supporting?
That's a difficult question. If you have a large impactor that we find, as you put it, say 3 days from impact, odds are there's nothing that can be done. You would have to try to evacuate as many people as possible. But again, in 3 days, the ability to do that with, of course, the reaction of people, and whether it's China or anywhere in the world, just the reaction to this would be devastating. Honestly, I really don't know whether I would want, if it were me, if I would want to know or not want to know. It's very hard to judge that. And again, it's going to go back to what can be expected from this object. How big is it? Is it going to reach the ground? Is it going to be an atmospheric impactor? So all of those things have to factor in. The key is to find these things early enough where we could do something about them. 3 days, there's probably nothing that you could do.
Yes, because this is an important area that, you know, the experts are still debating what is the best approach. As I said before, with so much fake news and everybody jumping on social media and sharing unauthorized information, we really can create a disaster even before the disaster occurs, just by scaring people and having them coming up with all sort of ideas on their own. So this is one of the efforts from the interagency communication, education, and outreach that we continue working on constantly. What are the best ways that we can keep our people informed globally? Okay, what are the processes? What are the right words? What is the right terminology? How do we get not just media, because even media does sometimes what they want to do, but now with social media and everybody jumping online, how do we create places where people can actually go and find the right information and avoid so much fake news, but also actually get the information for the trusted sources, which is some of the organizations that I share with you in my presentation. So yeah, that's all I wanted to add. It is an important thing to continue working on and keep in mind.
Thank you so much, Jeff and Nancy, for investing your weekend with us today. Thank you for the audience for your thoughtful questions. We'll address all of your questions in the future episodes. So thank you, everyone, and we'll invite you for our next episode. That's going to be again with NASA colleagues, Aerospace Propulsion Part 1, Air Breathing Propulsion Systems and Access to Space. So as soon as we log off here, you'll be able to sign and register for an engineering episode. Thank you, everyone, and stay safe this weekend and keep doing the great work.